simulation when is required and when is not required. Simulation is a computer program that creates a virtual environment in order to study and include any problems, including physical ones. But one thing have to be noticed, that all the target system have to be modeled as a discretized manner. And also this kinds of simulation is required when the target problem is hard to do the actual experiment, such kinds of the war, battlefield, or the very complex banking systems. And also the simulation is very helpful because it is cheaper than the actual experiment, the physical experiment. For example, the RTL simulation for the IC means that the integrated chip design, or highway or freeway routing planning can be simulated by use of discrete event simulation. We have already seen the actual example for the highway simulation in previous class. Also, in order to analyze the bottleneck of current system can be conducted by use of simulation. But the simulation is not helpful when the simulation itself is more expensive compared to the actual physical experiment. For example, the very simple harmonic motion of a physical system, it is easier to do to physical experiment rather than to make any complex simulation model by implementing the physical phenomena inside of computer. Also, the simulation is not required when the simulation output is not acceptable. It means that all the simulation results have to be verified and validated in order to use the result from the simulation is adapted to, not adapted, to represent the physical, the behavior of actual system. Also, we have studied the several categories of simulation. First category is continuous or discrete. And our simulation study is about the discrete systems. Also, second category is static or dynamic. Static means that this represents a system at a particular point of time. So in case of a static model, the time is not necessary. It means that the static model cannot represent the variation along the time. So this kinds of model, static model, can be simulated with a Monte Carlo method. And the simulation is aiming at dynamics. Dynamic represent a system as the time is varying. The last category is deterministic or stochastic. Deterministic system contains no random variable. But in case of a stochastic system has one or more random variable. In our simulation study, we will adopt both kinds of simulation. In case of the queuing model simulation, the stochastic distribution will be implemented in order to make in order to represent the cycle time and inter-arrival time by use of Poisson exponential or uniform distribution. But also, we will use the deterministic variable in case of the planning and scheduling simulation. In those cases of planning and scheduling simulation, we will use the predefined the working duration. It means that the activity duration or the predefined schedule. In those cases belonging to deterministic categories. So what is discrete event simulation? Discrete event simulation is firstly discrete ones. Also, discrete simulation handles the dynamic behavior of the system. And also, fundamentally, discrete event simulation can handle the stochastic distribution, but also, and very surely, deterministic behavior can be represented in the discrete event simulation. And mostly, but not limited to queuing systems, these kinds of the physical systems can be made. Firstly, factory workflow. And nextly, freeway or traffic systems can be simulated. Also, though it is not visible ones, but the network flow, that one of the kinds of network flow is the internet system. Network, the traffic, the behavior can be simulated also by use of discrete event method. Now, in terms of discrete event simulation world, we have studied there are several views that can implement a discrete event simulation model. First one is activity-oriented. In this case, the fixed increment of time, the method is used. In this case, it is not very efficient because it requires very the time. And in case of event-oriented approach, in this case, on each event, the simulator generates next event and put into this next event to the future event list. So in the case of event-oriented method, simulation time is not restricted to the predefined increment of time. Instead, in case of event-oriented approach, simulation time advances to next closest event. It means that jump to the closest time that will occur in the future time. So this is faster than this activity-oriented, it means the fixed increment of time method. Third one is process-oriented approach. In this case, it is very similar with event-oriented, but in process-oriented approach, one more thing is added. It means that this abstract one object into a process. So this process can behave like the very independent object. So if we use this process-oriented approach, it is far easier to implement, also far easier to maintain in the end. And the SimPy that we are going to study is belonging to the process-oriented approach. There are several kinds of methods when implement discrete event simulation. Firstly, we can use we can develop our discrete event simulation program by use the native the program language such as C++ or Java or etc. But this will take much time to implement our own code because we have to develop from the scratch level. So we have to implement one by one all the things. So also there are big possibility to debug because there are no pre-implemented the modules that let us know the point that error occurs. Also, if we develop our DS program with the native computer language, it is not very convincing because that is not the validated. So instead of use of the native program language, we can use a generalized simulation library or language. It means that these kinds of library is pre-implemented and let us make us the easily implement our discrete event simulation model. There are so many kinds of library. Maybe we have already here is open source. There are so many kinds of the open source library that we can use freely from CPN tools, Desmo or PowerDepth or Ptolemy, and there is a SimPy. So we can see here the computer language that is the basis of each open source, DDS open sources. The SimPy is the only one that is developed based on Python, the environment. So there are so many kinds of simulation library, and in this class, we will use SimPy. Here, the sim events in Simulink and MATLAB. Do you know that the DES can be made by use of MATLAB? MATLAB can be used for the implementation of discrete event simulation. And we can also use the special purpose simulation package. Those are the commercial ones. such kinds of analogic, arena, or Delmia, FlexSim, GoldSim, so many kinds of commercial software. Those softwares are very easy to use, but these kinds of commercial software requires very high cost. Also, yearly, these kinds of the software requires annual fee. So it is not efficient for the use of the academic research. Anyway, we will use SimPy in this class. So from now on, we will review the introduction of SimPy. The SimPy uses a Python language for discrete event simulation model. It is easy because Python is a scripting language. It's not compiling language. So it is very easy to start. Also, Python is free, so the developed environment. Also, very recently, the Python is developed as the language that is easy to code, make a code, and very beautiful language. And process-oriented DS language, as I told you, the SimPy is the process-oriented method. So it is easier to make a model and also provide fairly proven event manager inside of the SimPy. So when we use the SimPy language, this environment let us focus on algorithm code itself. Also, it is easier to use core routine to wait or resume the process. But one disadvantage of SimPy is this one. The SimPy cannot run on parallel machine for a single simulation. So this is the only disadvantage of the SimPy. Okay, there are several terminologies that we have to know. The first and most important terminology is the process. When we make the SimPy model, there are always the process. Process simulates each entity which involves in time. For example, the clock entity that serves customers, this activity can be modeled as its own process. Actually, this process is internally inside of the Python implemented as by use of the thread. Fortunately, we do not need to understand and to study about what is a thread. But the thread, by use of thread, the SimPy can implement and run the model of the asynchronized behavior of each entity inside of the model. Those asynchronous behavior of various entities in the simulation, it can be implemented because of the SimPy use the thread functions that is already implemented in the Python environment. Also, resource is the important terminology. The simulation, when this resource is used, when you simulate something to be requested and waited if not available at any point of time. For example, if we are going to make the laundry shop, the washing machine can be implemented as a resource entity in the simulation. The red colored word is not the one that we are going to study, because these kinds of the command or function was used at the version 2 of SimPy, but in this class we will use the version of 4, SimPy version 4. So these kinds of the old command is changed to very simplified way. For example, this one, yield request. This command was used when we need to implement a resource request. But in this new version, in version 4, we do not find this one. Also, now we do not need to make a release, because after the finish of the use of resource, that resource is released automatically. So this is, you don't need to study these ones. Skip this page. This is not the, today we will study another example instead of this, the clock and arrival example. So those are the references that were referred in today's slide, the materials. So if you have any one of you are interested in each detailed contents, you can refer one of these references. And from now on, we're going to let you know about basic concept of the SimPy. But before the start of this one, you can visit this address, because there are all the required the basic contents of the SimPy are documented already. Starting from the overview, the very simple examples, it is SimPy in 10 minutes. And this is the contents that we are going to study today. And also there are the topical guides from the basics, what is environment, how to treat the events or interactions between the processes, and about the shared resources, etc. Also, there is already documented the very useful examples. Also, we will also study the several examples in our class after next 2 weeks. Also, the API, application protocol interface, from SimPy, core, exceptions, events, all the internally implemented functions are documented also in the web page. Okay. Before the starting of the first example, you have to install the interpretation environment and Python, and also you have to install to make your own virtual environment. Have you installed the required environments? I'm going to check one by one. How about somewhere? Did you install all the environments for the SimPy? How about virtual environment? Yes. Do you?
Yes, I have two virtual environments.
Environments, and what do you going to use your coding environments? Actually, we have recommended the PyCharm, but
I have PyCharm. Sometimes I use Spider. Sometimes I use VS Code.
Okay, you can use your own environment.
Yeah.
정세용 학생은 어때요? 다 설치했어요?
저는 파이참은 설치 안 했는데 파이참 설치해서 한번 따라해 보겠습니다.
그럼 파이썬하고 그 뭐지? 버추얼 인바이러먼트는 설치했나요?
예, 파이썬 2.3은 설치돼 있고 스파이더랑 VS 코드 썼었습니다.
박정호 학생은 어때요? 안 들리는데.
다 설치되어 있습니다.
소리가 안 들리네. 왜 그러지? 다시 마이크를 켜고. 다 설치했습니다. 오케이. 여인상 학생은요?
저도 다 설치되어 있습니다.
오케이. 네, 맞아요. 왕슈강, 왕슈강,
네.
can you hear me? Okay. Did you install?
I installed PyCharm.
And also including virtual environment?
Yes.
Okay, very good. Okay, so we don't need I don't need to mention about the installation. So skip this one. These kinds of the SimPy installation. Okay, the SimPy is descriptive in the simulation, and behavior of the entity is modeled with the process entities. And all the process lives in an environment. We will see what is environment in our code. And all the entity will interact with the environment and with each through the events interactions. And processes are described by simple Python generator. It means that the generator function itself is the one that is belonging to the Python language. And the very simply and intuitively, the generator is used as the functions that consumes the time. So generator is used in order to implement time advancement. So we can call them process functions or process method depending on whether it is a normal function or the normal function means that the independent functions, or we can implement the generator function inside of the class. So during the lifetime of each functions or class, they can create events and yield them. Yield means that wait or consumes any amount of time. In order to when we study the SimPy, weight includes the weight itself. Also, weight means that the consuming time. So when we use the terms weight, sometimes it means the working time. So this weight means that any kinds of activities that consumes the defined the period of the time. And when a process yields an event, it means that when process creates event, the process gets suspended. Suspended means that this entity is changed to the state of the waiting. And SimPy can resume the process when another event occurs, and that if that event let this suspended entity to wake up, at that point, this suspended entity can be resumed. And also, multiple processes can wait for the same event. It means that a single event can trigger the multiple processes if each process contains the waiting functions inside of those functions or classes. And SimPy resumes then the waiting multiple processes in the same order in which they yielded an event. It means they create those events. And one of the important event type is a timeout. Timeout can be used for the waiting or for the working. Events of this type, timeout events, are triggered after a certain of time has passed, and they allow a process to sleep for the given time. In our view, our means that the implementation view, the waiting and working is a different type of activity. However, inside of the SimPy, those waiting or working is samely treated by use of this timeout, the events. A timeout and all other kinds of events can be created by calling the appropriate method of the environment that process lives. We will study later about the other kinds of event triggers. Anyway, this timeout is the most frequently used ones. In the descriptive and the simulation when we use SimPy. This is the first example that we are going to implement. All the SimPy program is start with this command. It means that from the SimPy package, we have to call the environment where our the processes and all the entities will stay in this environment and assign this variable as the environment. And from this environment, all the processes is triggered. This one. Events that process, and this process commands call this function or the class. So the things that we have to implement is this function or class. In this example, this is implemented as independent functions. This df means the functions. And if this function is implemented and added to the process, then after that, we can run the simulation. And inside of this run command, we can assign the finish time of simulation. If we do not assign any specific duration, this simulation will not be stopped, except the error occurs. And this example is like this. The car object, the entity will alternately drive and park for a while. While means that any specific duration. When this car starts driving or parking, it will print the current simulation time, not actual time, the simulation time. So this our car process requires the environment in order to create new events. And this car's behavior is described in an infinite loop. It means that this while, if we assign the true variable here, the while loop, then this loop will not be stopped until the external interruption occurs. 귀영이는 어떻게 하면 그렇게 얼굴만 동그랗게 나와? 이런 기능도 추가가 됐나?
이거 어플로 안 하고
어.
크롬 인터넷상에서 키면 이렇게 됩니다.
아, 얼굴 동그란 사람이면 달덩이 같겠네. Anyway, this function, we have mentioned the generator. Generator is not command. Generator is a method. So in this example, this function is a generator. It means that this function can create or trigger any event. Though this function will never terminate, but it will pass the control flow back to the simulation once yield statement is reached. In here, the yield statement, where is yield statement? Here and here. And by use of this yield function, we can trigger the timeout event. Once the yielded event is triggered, it means that this event occurs, the simulation will resume the function at this statement. It means that, let's see these functions. Firstly, print the start parking at any point of simulation time, and assign the parking duration as 5 units time. One important thing that you have to know is that there is no predefined the unit. It means that there is no predefined unit. It means that it is not hour or minutes or day. It is the unitless time. So we can freely define the units. If you define this time, this unit as the minutes, then this 5 will treated as a minute duration. Along the entire simulation. So it is very important to define the time unit inside of the simulation. Then first occurs this event. It means that by yielding this timeout event, at this point, the start of the suspended state during 5 units, the parking duration time. And after the 5 unit time, this event is finished automatically without needs of the external interruption. So after 5 unit time, this print is executed. And after this, with the given duration of time unit 2, the new event is triggered by yielding the timeout events with the trip duration time. So this loop is repeated infinitely until what? Until when? Until this time, 15 time units. So let's run this simulation here. This is the same code that we have seen here. We have seen a little bit different. There are several more print statements, and I have changed the time to 20. All the other code is exactly same. Firstly, this is the starting point of the simulation. Anytime when we implement our SimPy code, we have to announce the environment and put this environment into this env local variable. And from this local variable, we create the process. And this process take a car functions. And one thing have to be noticed is that when we define or when we create any class for the event trigger, the environment variable have to be assigned anytime to any class or any functions. This is very important point. So environment variable have to be assigned as argument of every, why is this up here? Every functions and every class, those for the event trigger. And from this environment variable, the run is triggered. So let's start this code. If we run this simulation, we can print here. firstly, this statement is shown. Start parking at time 0. And next statement, stop parking at 5, is this one. This statement, between this statement and this statement, there are events that consumes any amount of time. That is this yield statement. After this, I don't know how to stop this window. Between this statement and this statement, that is here, start driving and stop driving. And between these two statements, there are the yield statement, and this events consumes any amount of time, that is time unit 2. And this is infinitely repeated until this time, the assigned time. So this simulation is continuous to 19. If I change this to a different time, this simulation will repeat it until 100 times. If not, if there is no time defined, it's not stopped. It repeated infinitely. So we have to force it to stop this one here. Okay, this is the first example. Very, very easy one. So skip to the next example. This example is the clock, about the clock, and this example is for the how SimPy implement, how treat the asynchronized entities. Let me see very quickly this example here. If implement this example is behave like this, the time is too small. You can see here the fast clock and slow clock behaves independently. There is no sequence between fast clock and slow clock. You can see here the environment triggers these three processes simultaneously and insert three functions: fast clock, slow clock, and very, very fast clock here, these three. And implement each clock as like this. And only assign the other period of time here, 0.5, 1, and 0.1. In our the traditional procedure of the process, these three functions are executed sequentially. But in our SimPy environment, these independent three functions can behave independently. It means that asynchronous way. So when we start this simulation, these three functions behaves independently, regardless of the behaves of other entities. This example is like this, so skip this example. Okay, next example is about the waiting. the process instance that is returned by process, the environment that process can be used for process interaction between the different kinds of processes. The two most common example for this is to wait for another process to finish and to interrupt another process while it is waiting for the another event. So let's see this example. This part is always the same. Course environment and assign the car, in this case, we just create the car. And this car is created with this event. And in this case, we will create the car class instead of the independent function. And inside of this car class, we will define three functions. First, init function, and run function, and charge function. Because our example is treating the electric cars. So we will assign the charging. So please briefly review this code quickly. Okay, let's see how it is executed. When we create car class, and when we run the simulation here, the first part that is executed, and also only one time executed part is this initiation. In this part, the environment, this environment is coming from the outside as argument, and the self means that this car class. Self means the car class. So in order to use this environment inside of this class, we have to define this car.environment and assign this externally argumented environment is assigned. And from this self action, assign the process. So when we start this car class, this car class starts the process with this self.run. So automatically started from this point. This initiation function is executed only one time when this is triggered. This is started here. And after this, from this part, run. This run is not the environment run. This run is the functions of car class, and that is described here. Also, this function is the infinite loop by use of while statement. Firstly, print the start, parking, and charging. So in this part, we can know this car class is started at the state of parking and starting of charging. And charging duration is assigned here. And with this duration, this car class yield the car class and environment the process. So yielding this function. This is the hierarchical structure from the car class, and inside of the car, we call the run function. And from the run function, in here, when we trigger the process, we again calls the charging, the charge functions. The charge function is here. And this charge function is also the event triggering. The conduct event triggering. The triggering is this part. Yield the timeout event with the duration. This duration argument is coming from here. Charge duration. That is time unit 5. This time unit 5 is assigned to charge duration. And in this environment, that process calls the charge function. But this charge function also is belonging to car class. We have to call this function by referencing the self. Self means that car. Then car.charge, by calling this function, we can triggering this event inside of this process. So in this simulation model consumes 5 time unit. And after 5 time unit, this event is finished automatically, and this function can execute this statement. And after this car start trip with time unit 2. That is this event. This event is yielded by use of timeout event. The different part of this example with the previous one is that anywhere of each the event or yielding part is referencing the self. Self means that this car class. Okay. Now let's see how is it executed. So we assign the finish time as 15, and let's start the simulation. Very simple example. So this example is started at this point. At this point start, and this starting driving is here. So between this statement and this statement, there are one event, that is this one, the process of this car class. And in this part, this process calls the charging function. And in that charging function, again, appears this yielding. And this yielding function yields the timeout event. With this mechanism, this simulation can consume any amount of time. After this car conducts a trip, operates a trip, And after that time unit 2, this part, where is it? There is only one, start driving. And with this yielding function, 2 time unit is consumed. And after this, there is no print statement. And so this is going back to this point because this is infinite loop of file statement. And this will be repeated infinitely until given this time. The similar way with previous, if we change this time, simulation is continuous.